Welcome back to Falcon Physician Review's online review for USMLE Step 1. This is Microbiology Module 38. It's the introduction to the mycology section. We're going to start here by introducing you to different fungi and molds. We're going to talk about the most important clinical species which cause human disease, and we'll give a brief overview of the antifungal agents. This will be important, and it's a good way to come back and review right before the test so you can be familiar kind of from a broad perspective of fungal diseases in humans. Welcome back to Falcon Physician Review's online review for USMLE Step 1. This is Microbiology Module 38, Introduction to Mycology, Structure and Growth. Fungi are eukaryotic organisms. They do not contain chlorophyll, but they do have cell walls and form filamentous structures. Fungi are known for their ability to produce spores. They're not plants. They have their own kingdom Mycota. They're saprophytic, which means they derive nutrients from organic waste. The one exception for the fungi is Candida, which is part of our normal human flora. There are hundreds of thousands of species of fungi, but only a few affect human and cause human disease. The pathogenic mycoses are what we're going to review, and they can be classified by the body site of infection. Also, we'll talk about opportunistic mycoses. Molds promote the decay of tissue. Fungi are true human pathogens, and this is a list of a number of examples. Exophalia wernickeyi is the causative agent for tinea nigra. Malassezia fervor we'll be familiar with as the cause of pityriasis versicolor. It's a dimorphic fungus. Trichosporin cutaneum causes white piedra, and black piedra is caused by Piedra horte. The white piedra is sexually transmitted, and so we'll want to remember that. In terms of cutaneous mycoses, there's dermatophytes like epidermophyton, microsporum, and trichophyton. It's important to remember that epidermophyton does not infect hair, whereas microsporum does not infect nails, and you can get it from dogs and cats. In addition to cutaneous infections, fungi are known causes of subcutaneous infections. Actinomyadura madure, Cladosporidium, Madurella grisea, and Pileophora, in addition to Sporothrix schechniae, are known causative fungi which cause subcutaneous infections. With Sporothrix schechniae, you'll want to be careful for a history of gardening, especially being pricked by a rose thorn. Systemic infections caused by fungi include Blastomyces dermatitidis, Coccidioides immitis, Histoplasma capsulatum, and Paracoccidioides brasiliensis. All of these are dimorphic fungi. Opportunistic pathogens include Candida albicans, Cryptococcus neoformans, Aspergillus fumigatus, and the Mucormycosae, including Rhizopus orzeae, Rhizomucor pusillus, and Absidia cormifibria. Also, Pneumocystis carinii. You may be familiar with this list of organisms or more familiar with them because they frequently show up in AIDS patients who are immunocompromised. Also, you don't want to forget about poisonings and allergic reactions to fungi, including fungal toxins, fungal spores, which are allergens for people. Let's talk a little bit about fungal morphology. Yeast are what we call unicellular fungi. They show up in its one single cell. Whereas molds form hyphae, which are filamentous multicellular fungi. There can be non-septate or septate fungi, or you can have this mat-like mycelium formation. With the non-septate, there are no cross walls, and these form broad hyphae with irregular width. The septate fungi form cross walls, and they have a fairly regular width. You can have fungi which are dimorphic, which can have both a mold, a multicellular, or a yeast form, unicellular. You can also have yeast which form pseudohyphae. They're budding, but they remain attached to and do not separate from the yeast. So there are yeast and yeast-like fungi in addition. Structural components of fungi that you'll want to be familiar with include the cell wall. Some unique compounds include chitin, which is found in fungal cell walls and not in bacteria or humans. You'll also have N-acetylglucosamine. The fungal cell membrane has ergosterol in it, which is bound by amphotericin B and nystatin. Its synthesis is disrupted by the imidazoles and triazoles. Fungi are known to form spores, which is the basis of their identification. You can look at the conidia, which have asexual reproduction and they're pigmented, or you could have ascospores, which undergo sexual reproduction. Spore types are going to be discussed below. You can have conidia, blastoconidia, arthroconidia, or spherules or endospores. With the conidia, these are asexual spores. They're formed off of the hyphae, and they're common and they're frequently found airborne. Blastoconidia, you'll see more with blastomycoses, is where it buds off of a yeast. Arthroconidia are asexual spores formed by a joint, and spherules and endospores are spores inside the spherules. This table shows a lot of the unique characteristics of fungal staining and the frequent stains that we use to identify fungi. So you have the KOH wet mount, which is good for most fungi, PAS, silver stain, and calcifluor white. Finally, you can do India ink, a wet mount of CSF sediment. This is very good for Cryptococcus. I would review this table as it will be important and frequently tested on in step 1. Culturing fungi takes several weeks, and you often have to have special medium, such as Sabarod's agar. It requires a low pH and a mycocell agar with chloramphenicol and cyclohexamide to inhibit bacterial growth. You also have special additives and recipes depending on the fungal species involved. You can often visualize them at 25 degrees and at 37 degrees, where you can find out their cellular morphology and their spore morphology. You will have urease-positive yeast like Cryptococcus and T. Biageli. This figure overviews the targets for cell wall metabolism in fungi and the antifungals we use, which steps they inhibit. So as you see on the far left, amphotericin and istatin can form artificial pores which disrupt fungal membranes and cause cell death. As squalene is transitioned into ergosterol, there are 2 steps which are inhibited. The most frequently one is from lanosterol to ergosterol, blocked by the azoles. As you form nucleic acids from their precursors, flucytosine is going to block that process. And problems with microtubules are often caused by griseofulvin, another antifungal we frequently use. That's it for Module 38, where we did Introduction to Mycoses. We also talked about structure, and we talked about antifungal drugs. It's important to remember that the fungal cell membrane is different in a number of key characteristic ways. The presence of ergosterol, its synthesis, is a major target of the antifungal drugs. In Module 39, we're going to talk about the superficial mycoses, and we'll go in greater depth of each fungal unit and how we treat it. Wrapping up Module 38, like I said before, this is a good one to review right before the test. It's an overview of fungal disease. We talked about each of the clinically important species. We differentiated between molds and yeasts. We talked about the different spore forming techniques. We talked about the media and different ways for diagnosis. We broadly overviewed the different parts of your body that can have fungal infections and the antifungal agents that are available to us now. In 39, we're going to go to the superficial mycoses and start in more detail about these group of fungi.